Good morning, everyone. I see people are coming into our webinar. I think we can begin. First, welcome to the EOSC-hub webinar, an EOSC-hub proposal for the EOSC Technical Architecture. Before we begin, let me just provide you with an introduction into how this webinar works and how you can interact with us. As an attendee, you have a sidebar where you have the functionalities to raise your hand for the question and answer portion at the end. If you raise your hand during the Q&A portion, we will unmute you so you can introduce yourself and state your question. Please keep your questions until the end of the presentation, just in case some of your questions are answered in the later slides. Please note that this webinar is recorded, and both the slides and the webinar will be posted in the EOSC-hub website before the end of this week. Specifically, this webinar listing, specifically under the webinar listing under the events section. So today's webinar will describe the reference technical architecture for EOSC proposed by the EOSC-hub during the recent EOSC-hub Technical Workshop. The proposed architecture is based on the concepts of service composability and interoperability. Service categories and relationships between them will be presented. The process to define interoperability guidelines for different technical areas will also be shown today. Our speaker today is Diego Scardacci, who works for the EGI Foundation and is one of the co-chairs of the Activity Management Board of the EOSC-hub project. He is also involved in the Technical Coordination Work Package, leading the EOSC-hub technical support activities. In this webinar, he will present the current status of the EOSC-hub work on defining a proposal for the EOSC technical architecture. Over to you, Diego.
Thank you very much, Rob, for your introduction, and thank you everybody to have joined this webinar. As said by Rob, in this webinar, I will present the current status of the EOSC-hub proposal for the EOSC technical architecture. This is, I would say, is a work that we started some months ago, and it culminated with a workshop organized by EOSC-hub at the end of June in Amsterdam, and now is continuing or is enhancing, and I think it's around the time to start to share the output of this work with a larger audience, to collect feedback, suggestions, to improve our approach, and so on. Let's start. Okay, this is the outline of my presentation. First of all, I'd like to give you some information about the landscape where we are working. Then I will say a few words about the past experience that has been done on trying to define the EOSC technical architecture. Then I will introduce some basic concepts that are fundamental to better understand our approach to define the EOSC architecture. First of all, the proposed the EOSC portfolios and the EOSC federating cost structure and the service composability concept. Then we'll move to the key part of the presentation, the EOSC approach to define the technical architecture, and I will complete the webinar with some words on the use case analysis that is driving our work, and with some conclusions and information on the next steps. So let's start with the first topic, the landscape. As many of you probably already know, in the 2018, the European Commission delivered a Commission staff working document with the implementation roadmap of the EOSC. In this document, 6 lines were identified: architecture, data, services, access interface, rules, and governance. And the work I'm going to present today will focus on the first line, the architecture. As architecture, the Commission intends the architecture of federated infrastructure as the solution to the current fragmentation in research data infrastructure, which are insufficiently interoperable. You can see the word interoperability is mentioned, and you will see this is a key word on the definition of the EOSC technical architecture. Another important information, I think you need to know to understand the landscape where we are working on, is about the EOSC working groups that has been set by the EOSC governance in the last months. One of these groups is the architecture, is working on the architecture, and its main objective is the review of the current offering and the required evolution of the EOSC technical architecture is standard and best practice. In particular, the EOSC architecture working group will describe and define EOSC core services and their interface, EOSC open source API for use by thematic services, EOSC portal components and federated catalog of service offering, the EOSC data description standards, and standards and best practices to allow the evolution of EOSC and its widening, the widening of its user base to the industry and the public sector. Obviously, in the work we are doing, we have to take into account the EOSC architecture working group, and it should be, I would say, our first reference. And we have to discuss with the people within this working group. Anyway, EOSC-hub is also represented with the one person within this working group. Now, a few words on the past work. In particular, I'd like to talk to you about the effort of the EOSC pilot project. The EOSC pilot project did to define the first EOSC service technical architecture. They developed a model and they analyzed this model from both a user and a functional perspectives. In the slide, I focused in the functionality perspective, since I would say it's more close to what we are doing in EOSC-hub. They identified 47 classes of services split in 5 categories: front-end services, then to access, the EOSC, the security and trust, aiming at guaranteeing that the overall access system is well operated, open science, data management, analytics, then EOSC system governance and management, dedicated to supporting the operation and management of the overall EOSC system, a computer cloud platform. This is the architecture they envisaged. You can see there are these 5 main blocks, and within each of these blocks there are specific functions that has been identified. I would say the work that I'm going to present is using a similar concept and is leveraged on the past experience that was done in the EOSC pilot project. The other past work I would like to mention is the EOSC-hub Technical Architecture version 1. This is the first deliverable EOSC-hub completed about the EOSC-hub Technical Architecture. I would say in this deliverable we identified some key concepts that now we are using on further defining the EOSC technical architecture. First of all, we detailed the different service types we can have in EOSC with their functions, the relationship with other components of the architecture, and the relationship with the end user. Then we introduced a very important concept, the end-to-end composition services that would allow users to compose workflow services. Then we also described how to extend the EOSC-hub with onboarding new services, how the services are offered via the hub, and the last but not least, standards and protocols adopted by the different technical areas we are working on in EOSC-hub. This is very important to foster the interoperability of the services. This diagram show you is extracted from this EOSC-hub deliverable and show you how a thematic service can leverage on different classes of services offered by the hub: federation services, common services, collaborative services. Now let's move to the after we completed this quick overview of the past activities on defining the EOSC technical architecture, let's introduce some basic concepts that are important to understand the current approach. The first concept of I would like to describe you are the EOSC portfolios and the EOSC federating core. We envisaged in the EOSC 2 different service portfolio. The EOSC service portfolio that contains thematic services that are community-specific services that provide value to researchers, like those offered by the research infrastructure, and common services that address technical needs that are common to multiple research areas and can be used by multiple thematic services. Usually the provider of those services are the infrastructure. Then we have a second portfolio, the app portfolio, that contains access enabling services, so services enabling the access to the EOSC, like for example the EOSC portal, then services to discover the services or workflow enabling, and federation services that would allow the operation of the EOSC, like a common help desk, accounting system, monitoring system, AI, and so on. The services in the app portfolio can be used by the thematics and common services to implement common functions. So a thematic service can decide to adopt one or more of these services, so the provider doesn't need to implement them by itself. In addition, we introduced the concept of the EOSC Federating Core, also called sometimes EOSC platform, that contains the app portfolio and other two components. The compliance framework, that is a set including the rules of participation, then the minimum rules to join the EOSC, and the EOSC service management system that is being developed by EOSC-hub. The third element are the shared resources that are generic data processing services, public good data, for example, the Copernicus data, or commodity services that are offered centrally by EOSC for the benefit of the service provider and its users. These concepts are very important, and I presented them you to understand how we classify the services, since we will use this classification in our proposal for the EOSC technical architecture. Now, let's introduce the second important concept, the service composability. Okay, on the right, you see another way to present the two EOSC service portfolios, the EOSC service portfolio and the portfolio, in particular with the federating core. On the right, you can see, I would say, a detailed view of the hub portfolio on the top, where you can see there are the marketplace, the AI, the accounting, and the monitoring. On the bottom side of the slide, you can see a detailed view of the common service that as part of the EOSC service portfolio, where we have orchestrator, data management, analytics, and so on. Services, these two sets of services can be seen by thematic services willing to join the EOSC as a la carte menu. Then it means each thematic service is free to select, to choose one or more of these services and integrate them with its thematic service. For example, the provider of the thematic service 1 decided to integrate its service with the marketplace, then to list the service in the EOSC portal, and to allow people to order the service via the marketplace, and the AI. So I would say this is a lightweight integration with EOSC. Instead, the thematic service 2 selected many services of their portfolio. Then, in addition to the marketplace and the AI, they also are using the accounting, the monitoring, the central help desk, and they also integrated the service with some common services. Then this, I would say, is a tighter integration with EOSC. This is the service provider is completely free to choose the integration best fit with its own needs. Now, let's say some few words on the service composability in EOSC. As the service composability, we intend the ability for the EOSC service provider user to compose different interoperable services. So, to enable the service composability, we have to identify subclasses of interoperable services. Then I would say some services can be already be interoperable, since, for example, they are supporting common standard. And we can also extend this subclass of interoperable services with integration activities. Integration activity that should be driven by the user requirement. So if there are two services that are requested by many users, and the user requested to have a combined usage of these services, this is a good reason to start an integration activities. An example is, for example, if there is a thematic services willing to exploit together the EGI Cloud Compute and the UDAT B2Safe services. Typical service combination are the reusing of federation services to implement a basic feature, like the AI, the monitoring, and the accounting, adopting common service to better exploit computer storage and data resources, and creating a new scientific workflow. In the bottom of the slide, we have two examples. The first example on the right is an example that is an integration, is a composition services that requested some integration activities. So the EOSC technical support should enable integration working with the community that requested this integration. Obviously, when this integration will be completed, the solution of integrated services can be reused in similar use cases. So when we complete an integration activity, we are extending the subclass of interoperable services. The example on the right is a bit different since we considered two services. The CareerDIAS Data Hub, that is one of the DIAS funded by the European Commission to better exploit the Copernicus data, the observation data from the Sentinel. And the Sentinel Hub, that is a presentation layer that can query a database of Earth observation data and can create special maps according to the needs of its user. Both these services support the same standard, the OGF WMS. So in this case, the services are already interoperable, so no integration activities needed, but the EOSC technical support can only help the community to use these services in a combined way. So you can see we can have services that are already interoperable since are supporting the same standard, services that can become interoperable thanks to some integration activity. Composable services is the ground to build the EOSC technical architecture, since we think the interoperability is the key concept that should be behind the EOSC technical architecture. So to increase the set of composable services, we need, first of all, to identify services that can work together, that are adopting the same standards and interfaces, and allow users to recognize the services when they access the EOSC portal. Then we can select the services interoperable with integration activities driven by use cases. This integration activity would be easier if we have, for the specific technical sectors, interoperability guidelines that suggest standards, API, that would fit within, I would say, the EOSC world. Finally, when we have identified services that can work together, we should allow other communities to use these integrated services. And when needed, we have to provide technical support to enable this combined usage. Okay, that's all for the basic concept I wanted to introduce you before to go to the key part of the EOSC-hub proposal for the EOSC technical architecture. Now I will describe the approach that we decided to follow. First of all, we think EOSC is something complex. We think it's something that still needs to be further defined. So we thought defining a reference technical architecture would be the right way to proceed. As a reference architecture, in the field of the software architecture, enterprise architecture, we intend a template solution for a particular domain. Usually a reference architecture provides a common vocabulary to implement it, and often this reference architecture aims to stress the commonality, so the interoperabilities. A reference architecture often consists of a list of functions and some indication of their interfaces. And the reference architecture can be defined at different levels of abstraction. So, given this basic concept about reference architecture, we decided to work, first of all, at infrastructure technical level, and to define, in the EOSC technical architecture, the main blocks, its function, its interfaces, and then the related APIs and standards. And also, we would like to have to define a common vocabulary that can be used within EOSC technical activity, and it can be also adopted by providers that will join EOSC catalog in the future. So, with this basic concept in the mind, and with the idea to identify the main blocks of the technical architecture, taking into account the basic concept we introduced before, in particular the classification of the services in thematic services, common services, and access enabling and federation services, this is the result. This is the, I would say, the high-level technical reference architecture we envisaged. You can see we have the user on the top. The user can exploit thematic services, or he can also decide to exploit directly common services if he likes. The user can access thematic services directly, so can directly link to a thematic service, or can leverage on EOSC access enabling services like the EOSC portal or other portal marketplace to access these services to a GUI or to some API. The thematic services can exploit data compute storage resources, also the part that will be offered as shared resources within the federating core, or directly, or using one or more common services. In addition, you see on the left of the slide, there are the federation tool that would allow, that will provide some basic feature like the AI, the accounting, the monitoring, and the help desk, then it can be used by both thematics and common services. Okay, this is, I would say, a simple schema. This schema will describe the main blocks of our proposed EOSC technical architecture. Now we have to work on defining the content of these main blocks. So we have to define the content for the blocks related to the access enabling and federation services, for the common services, for the thematic services. The EOSC portal is a special case, is a special access enabling services, it's a very important services, and since the design and development of the EOSC portal is done in joint activities also with other also with other initiatives, we don't cover it within this work, but in any case, I put some slide later where I can show you the current status of the EOSC portal. Example, within the federation service, our major function is the help desk of the accounting. Then, after we have identified the macro feature for each block, we would like to define a technical specification for each macro feature that will include high-level architecture and interoperability guidelines. So some rules that explain how a service can be made interoperable with another service that is compliant . Rob, sorry, is there any issue with the audio?
Hi, Diego. Yeah, it seems your audio is being cut. Could you just maybe repeat the last 3 minutes of your presentation?
Okay, I can start again from the common approach. Oh, sorry. Okay, so as I said, the idea now is working on defining the content of the main blocks of the EOSC architecture. We decided to follow a common approach for the blocks, and this approach consists on, first of all, identify the macro features offered by each block of the architecture. Then it means the main functions that will be offered within this block. Example of this can be, for example, for the access enabling federation service block, can be the AAI, the monitoring, the help desk. For the common service block can be, for example, the cloud infrastructure as a service virtual machine management. Then, once we have identified all the macro features for each block, we would like to define technical specification for each of these macro features. This technical specification should include an high-level architecture and interoperability guidelines. Then it means made instruction to make services that are compliant with this technical specification able to work together, able to interoperable. The technical specification should not be related to any specific real service, but should be abstract and describe the macro feature and the related specification. So this is the concept. For defining this technical specification, we created a template. These are the 5 main sections of the template. First of all, we have an introduction where there is a short description of the macro feature. Then we have the high-level service architecture, that is the reference architecture for this macro feature, with highlighted the interfaces towards the other macro feature, and it does not refer to any specific service. The adopted standard, listed with reference of the main adopted standards and the protocols API, and the interoperability guidelines, describing how similar service compliant with this specification can be made interoperable. At the end, we have example of solution implementing this specification. Only in this section, we have real services, only presented as example of services compliant with this specification. Already, this is a complex work, so the idea is to have an iterative approach to both identify the macro feature per block and improve the technical specification. Macro feature can be a lot. Then we are starting from the most relevant, taking into account the use cases. And we are defining that we are already working on defining the technical specification about this most relevant macro feature. And the idea is to get feedback on this and to involve also external people with expertise in the area covered by this macro feature to improve the technical specification and also to get, I would say, to get a general agreement about this specification. So with this approach, the idea is to have not one service per macro feature, not one use service per macro feature, but a family of use compliant services per macro feature. Services in this set will be compliant with the related use technical specification. Services in this set will be able to interoperate. Example of this set are, for example, the AI service compliant with the ARC blueprint, or a monitoring system or accounting systems that are able to exchange, share information. Now that after I described the general approach, let's go block by block to see what is the current status of the work. First of all, we will start with we joined together the access enabling the federation service blocks, and we started to identify the components, the macro feature within this block. First of all, in these blocks, in the access enabling federation blocks, we intend as a macro feature any key access and federation enabling services needed to operate the EOSC. To identify these services, we will leverage on the experience from large European infrastructure, and the services that will be part of this block will be the services in the hub portfolio. I put in the slide the current list of services we identify, that we have the AI, the helpdesk, the accounting, the order management, the EOSC portal as special service, the operation portal, the messaging, and so on. Obviously, this is an initial list that can change according to the experience we will do, according to the feedback we will get. Then, after we identify the macro feature, now we are working on defining the technical specification for each of these services according to the template I showed you before. I put in the slide an example, one of the most mature, the AAI. This is one of the most mature thanks to the work done by the ARC project. On the right side of the slide, you can see the high-level service architecture defined for this macro feature, the AI, that is based on the concept of the community AI and the infrastructure proxy defined within the ARC project. On the left of the slide, you can see a table with the standards that are suggested as EOSC standard within this specific macro feature. Then we can move to the interoperability guidelines. For this specific AI macro feature, two sets of interoperability guidelines has been defined, the technical interoperability guidelines and the policy interoperability guidelines. You can see an extract in the slide, but the idea is that services that are compliant with this specification are interoperable. And finally, we have the solution compliant with this specification that for this specific case were classified in three different sets: AI services, identity and access management service, and token and translation services. Now, let's move to the common services. A common service is a service that is on top of the EOSC resources that would allow to exploit better these resources and can be used by multiple thematic service. So in this context, a macro feature in the common service block should be intended as a technical function that offers added value on top of the EOSC resources and can be adopted by multiple thematic services. Example of macro feature as the infrastructure as a service, virtual machine or container management, the cloud orchestration, metadata management, making scientific artifact fail, and so on. A macro feature, there is no mapping one by one macro feature service, but a macro feature can be offered by one or more generic service, or service can offer more macro features. The common service block is a very big block, so the number of relevant macro features in this block can be huge. So to further define the common service work, we needed to split the work, and we decided to do it splitting the work in different technical areas, leveraging on the technical areas EOSC-hub is working on. In addition, also within each technical area, we need to give priority to the different macro features. So we are starting with the most relevant for the users according to the use cases and requirements. So, as I said, we split the work leveraging on technical areas. We considered the EOSC-hub technical areas working on common services like HPC, HPC compute, cloud compute, PaaS solution, data platform for processing, data platform publishing open data, and so on. Other technical areas can be added. We added the area where we have the knowledge, but other technical areas can be added as suggested by other initiatives. For example, we are collaborating with OpenAir, and they suggested to add the scholarly communication technical area. So, this is the original EOSC technical architecture with the main blocks. Now, within the common services, we have this logical split in technical area. I put for convenience only 4 technical areas within the common service block, but this is only an example. So the idea is now to identify within each of these technical areas the features, the macro features, the most important macro features, and the related and defining the related interoperability guidelines with suggested EOSC standards and interfaces. Obviously, the technical areas are only a logical split, useful only for identifying the features, but they will not be part of the EOSC technical architecture. As I said, we had a workshop on end of August in Amsterdam to work on this aspect, and we already have a long list of macro features we have identified for each macro area. For example, for the HPC compute, we identified 3 different macro features: the multi-tenant job submission, the multi-tenant container-based job submission, and the HPC clusters on demand. For the cloud compute, we have infrastructure as a service, virtual machine management, orchestration, and container. We have a long list for the PaaS solution. For data platform for processing, we have the transparent data processing using POC6 in a distributed and hybrid cloud environment. For data publishing and open data, we have the data repository. For the workflow management and user interface analysis, we have the big data analysis, for example. And at the end, we have the additional technical area suggested by OpenAir, the scholarly communication, with all the macro features that has been suggested by OpenAir. Now, we are working now to make homogeneous and merge the 2 different efforts. Now, after we have identified all these macro features, as I said, we already started to define the technical specification according to the template I showed you before for all these macro features. An example is the cloud infrastructure as service virtual machine management. You can see on the right the high-level service architecture with highlighted the main components and the interface toward the users. You can see on the left the standards and API. We have different interoperability guidelines. We have a set of general interoperability guidelines. For example, a cloud IaaS virtual machine management should provide API access for on-demand management of virtual machine and associated resources, or open and all standard APIs are preferred. Service that provide the capability to manage virtual machine to graphical dashboard to limit API access to users cannot be considered interoperable. So some general rules related to the interoperabilities. And then we have some specific interoperability rules related to the AI, the orchestration, the federation, interoperability, and so on. Solution compliant with specification, we have 2 services on the left of the slide, the Agile Cloud Compute and the Agile Cloud Container Compute. On the right, we have 2 open source cloud frameworks that would allow to implement services compliant with specification. After we complete this work, the EOSC technical architecture will appear as I'm showing it now. The common service block contains a certain amount of macro features that we have identified. Each macro feature is specified, and each macro feature has its own interoperability guidelines and the suggested EOS standards and API. Obviously, the set of macro features shown in the diagram is only a subset as an example. So, for the thematic service, would be easier exploiting the common service, since the interface to exploit these common services is public, is shared, is agreed. So this would allow to foster the service concept composability concept we introduced before. In addition, having so well-defined interface would allow an easy interaction between the same macro feature within the common services. So the macro feature can work together to better serve the thematic services. This is how we envisaged the EOSC technical architecture, and this is what to say, the slide is the one that best reflects the current status of our proposal. Anyway, another important component of the EOSC technical architecture are the thematic services. So we need also to define the content of the thematic services block. We can use the same process, identifying macro features, but as a macro feature in the thematic services, we intend a technical function that is discipline-oriented and can be used in multiple thematic services. A disciplines-oriented macro feature need to be identified and specified by expert of the specific discipline. So EOSC-hub can start this effort thanks to the different communities that are participating in the project, but what we expect that this will be further defined and developed by community-oriented projects that need to be involved in this effort. So when this work will start and then this work will have its first output, the EOSC technical architecture will appear as in this slide, where also within the thematic service block, we have the different features. Okay, now as I promised, I would like to say a few words on the EOSC portal, since it's an important component of the EOSC technical architecture, but is not developed only by EOSC-hub, but is joined, designed, and developed by a series of initiatives like EOSC-hub, OpenAir Advanced, InfraCenter, and so on. This joint work delivered an EOSC portal concept paper that I would invite you to read. The link is in the slide. And in this concept paper, there is an agreed architecture that you can see now in the slide. You can see in the main square in the center of the slide, we have 4 components. The 2 components on the bottom are for the EOSC providers, and in particular have the EOSC resource catalog that contains services research product, and the registration and management dashboard that would allow our providers to manage its entries within the EOSC portal. Then we have the 2 boxes on the top, the EOSC resource registry and my service dashboard. This is for the EOSC customers that the EOSC resource service would allow to browse, search, access, and other EOSC services and the research product. And through the My Service dashboard, the customer can get information about the current status of its order, manage SLA, get reports, accounting data, support, and so on. The EOSC portal is connected with the EOSC AI to provide a unified access channels to the EOSC, and that will be compliant with the ARC blueprint, and a series of service management tools that are the federation tools that we mentioned before in our architecture: accounting, help desk, order management, and so on. How EOSC portal is enhancing. There is a EOSC portal collaboration agreement that is going to be signed in these days that will cover the activities until December 2020. It involves EOSC-hub, OpenAir Advanced, a key technical partner for my InfraCenter project that ended. It includes 4 joint activities: operation, then operating the EOSC portal according to the EOSC service management system being developed by EOSC-hub, improve the interoperability framework, technical integration, in particular to optimize the integration of the current EOSC portal service catalog and marketplace to have at the end a unique service catalog exposed in EOSC portal, and content provision. After this year, starting very probably from January 2020, the EOSC portal will be further enhanced from a technical point of view by the project that will be funded under the call Infra EOSC 06. That maybe it will be the EOSC enhanced proposal that include a series of key EOSC stakeholders. The EOSC enhanced, the project funded under this call will enhance the EOSC portal from a technical point of view, while in the 2020, the operation of the EOSC portal will be delegated mainly to EOSC-hub. There is an error in the slide. I'm sorry. The EOSC portal collaboration agreement will end on December 2019 and not 2020, and before the expected starting of the project that will be funded under the call Infra EOSC 06. Now, I think it's important. I know the presentation is quite long, but it's important, I think, saying some few words about the user requirement we collected from the use cases analysis. In the approach we are following is key. A key part of the process is identifying the macro feature that need to be specified within the several blocks. To identify what are the most relevant macro features, we analyzed quite a big amount of use cases. In particular, we referred to the work done by the EOSC pilot project with the scientific demonstrator, and the work EOSC-hub is doing with the thematic service, the competence center. Another source of requirement is the EOSC-hub community requirement database that contains requirements collected by communities that decided to use the EOSC after the launch of the EOSC portal. I put in the slide a subset of communities that we taken into account, but it's only a small subset of the total number of communities we considered. How the use case requirement are related to the work we are doing is shown by this slide. We are defining technical specification in the Interoperability Guidelines. For each of these, for the technical specification of each macro feature, we are taking into account the requirements to be collected. For example, for the cloud computer guidelines, we have to take into account the requirement how to make your service scale out to third-party cloud for compute-intensive workload. For the AI guidelines, we have to take into account the requirement how to make a user able to really having a single sign-on accessing more service. For the metadata guidelines, how to define a metadata schema, and so on. So this is not all the technical activities, but is taking into account the real user needs. So the specification should be in line with the needs of the user. Okay, now I'm moving to the last part of my presentation with some conclusion and next steps. First of all, at the start of this webinar, I introduced you the EOSC architecture working group and its objectives. Now, I would like to say how the approach we are following, the objective of the approach we are following are mapped to the objective of the EOSC architecture working group. One of the first objective for the EOSC architecture working group is defining the EOSC core services and their interfaces. This can be mapped in our work to the definition of the EOSC access enabling and federation services and interfaces block. For then, the second objective of the working group is defining EOSC open source API for reuse by thematic services. This, I would say, can be mapped with the interoperability guidelines for the common interface, for the common services, and the interoperability guideline for discipline-specific services. Then we have the third objective, EOSC portal components and federated catalog of service offering. This is mapped with what I just described, the joint work on defining and developing the EOSC portal, and the definition of the EOSC service portfolio I introduced at the start of the presentation. Then we have standard and best practices necessary to ensure the evolution of the EOSC and the widening of its user bases to the industry and public sector. Also, in this case, this can be mapped to the interoperability guidelines for commons and thematic services. Finally, we have the EOSC data definition standard. This is something that needs to be taken into account in the feature working with the metadata. Now, I would like to show you our plan, the current status, and then including the next steps. The first step of the plans we defined to, I would say, for this work within EOSC-hub was to organize the technical workshop in Amsterdam with the participation of the main infrastructure. I would say this is done, and the output of this was some recommendation for EOSC technical architecture, reference architecture, and guidelines principle I just described in this webinar. Then the second step is starting having the one when we identified the most relevant macro feature we would like to work on, having the first technical specification for all the set of services, access enabling, federation, and common service ready, and starting a public consultation. This is ongoing since we are complete. We already have some set of specification ready. We are completing some other specification, and would like to start this public consultation very soon to have really strong specification. Then, also in summer, autumn of this year, we would like to collect feedback and suggestions on the whole approach we are proposing. So the idea was to organize webinars, to sharing documents and so on, and this is also going. The webinars, the today webinars is the first step about this feedback collection, and after this webinar, we will share with you also a brief document with a short questionnaire to get more feedback on this approach, to understand if we are going on a good direction and to get any suggestion to improve our effort. Then, for the second half of the year, we planned two actions. One on autumn, we would like to organize another EOSC architecture workshop, but this time as open-air event, trying to involve all the most relevant EOSC stakeholders, and possibly in collaboration with the EOSC architecture working group. It is planned for the autumn of this year, and then by the end of the year, we would like to have a consolidated proposal for the EOSC technical architecture, and we would like to have it shared with the EOSC architecture working group. That's all for my presentation. I put also my mail in the slide if you would like to contact me for any further clarification. And I think we can open the question and answer phase.
Thank you very much, Diego, for your insightful presentation. Now we're moving on to the question and answer segment of this webinar. So we invite you to please digitally raise your hand so that we can unmute you. Remember to please introduce yourself by your name and organization you represent, and to state your question after. Please limit your follow-up questions to give others the chance to ask their own questions for the others. So just limit your follow-up questions to one. So let's see, we have our first question from Kostas Koumantaros. We're unmuting you now. Please introduce yourself and state your question. Kostas, are you there? Okay, so while we're waiting for Kostas, we'll get back to you in a bit. I see we have a question from Sebastiano Buscaglione. You're now live.
No, sorry, I didn't raise my hand. I was asking a question previously about the audio problem.
I see. Okay, sorry, it was just marked here. All right, thanks. Are there any other questions from the audience? I see Arnaud Gold asking a question. You're now unmuted. Please introduce yourself and state your question.
Hello, so I'm Arnaud Gingol from Opera's RI. I have two short questions. Thank you for the presentation, and I will be happy to see the questionnaire you will send. I wanted to know about the scholarly communication work and macro features you're identifying, if there are already some public documentation on this. Maybe you said this and I didn't check. If you have some links, public link to share, we'll be happy to read it. And the other question is very specific. I saw the marketplace on the EOSC portal, but I didn't really understand what it was and what it does. If you can give some details on this. Thank you.
Okay, thank you very much. For the first question about the scholarly communication, we don't have yet the, I would say, official technical specification. This is something work in progress, but I have some materials that OpenAI prepared for the technical workshop I can share I can provide you with a link with a presentation of an area prepared on scholarly communication. When the specification, instead of your taking a specification, will be ready, that will be shared, and I would say we are going to define common channels to share our taking a specification, so you can easily find them. For the second question, is also related to the marketplace, and is how it works within the EOSC portal, right?
Yes, it is. Yes.
Yeah, the marketplace currently in the current version of the EOSC portal, there is a split of the service catalog into service catalog, one containing the services that can be only listed. Then you can get information about this service, and that's all. And then there is another service catalog that also provide, I would say, the possibility to order the service. This is the marketplace feature. Then the possibility to submit an order for a specific service with custom parameters, so you can customize the service according to your needs, following the marketplace interface, and submit an order. Then this order will be managed by the provider of these services that will contact you, that would allow you to access the service according to the condition behind to access this service. And this can also trigger some EOSC technical support activities in the case, for example, you decide to order multiple services and you have the need to use them in a combined way. As I said, there is an activity that is ongoing and should be completed by the end of this year within the EOSC portal collaboration agreement to optimize this structure in the EOSC portal, having a unique service catalog exposed in the EOSC portal with the marketplace feature provided only for the services that wanted to be available within the EOSC portal.
Okay, thank you.
Welcome.
Thank you very much, Arnaud. Is there anyone else who has any questions for Diego? I see a question from Matthew Villian. You are now unmuted. Please introduce yourself and state your question. You have to unmute yourself, Matthew. Yeah.
Hi, Diego. Matthew Villian from ETR Foundation. In some of your slides, you mentioned standards, and my question is, where do you think EOSC-hub should fit in the case that existing standards are not sufficient or don't exist, especially in relation to other bodies, for example, W3C and RDA?
Thanks, Matthew, for the question. In general, EOSC-hub will not work on defining standards. EOSC-hub is working on analyzing a certain technical areas related from, for example, relationship to a macro feature, to understand what are the most relevant standards in this area, and trying to get, I would say, an agreement on selecting a certain number of standards to become EOSC suggested technical standards. And this will be done to foster the interoperability of services. In the case there are areas where there are no specific standards, EOSC-hub in any case will not work on defining the standard, but will, I would say, raise the gap to people working, to specialists working on the specific technical area. So in general, this work will be valid if for each macro feature we will do a good analysis of the landscape. We identify the most relevant standards currently used by the researchers, by the service provider, and we get a general agreement of people working on the specific area on suggesting 1, 2, 3 standards as EOSC standards.
Thank you.
Welcome.
Thanks, Matthew. Are there any other questions from the audience? Okay. If there aren't any more questions from the audience, then I suppose we can close the webinar. I'd like to thank 50 of you for your questions and interest in the EOSC-hub webinar today. Just to note, the slides and the webinar recording will be published on the webinar event page on the EOSC-hub website within the week. So I'm pasting in the chat box to everyone the link. So that's where you can find the slides and the webinar recording, which should go up within the week. But this can also be found by going to the EOSC-hub website and going to the events section and then to past events. So we look forward to seeing you in our future engagement activities. If you want to be informed, please follow our new LinkedIn page that I'm now posting as well on the chat box. If you haven't followed us, be sure to do that. Any other parting words from you, Diego, before we end?
No, I would like only to thanks again everybody to have attended this webinars. I am available to provide more clarification by mail, so feel free to contact me anytime. And as I said, we are preparing this material to get feedback, official feedback from you, and we hope to have it ready next week.
Excellent. Thank you very much, everyone. Bye.
Thank you. Bye-bye. Thank you.